All right, we're back. We're back, and we're back with a nice multi-chat setup. Not too bad. Maybe gotta make these smaller. Let me mess around with that. Looks pretty good though. We have proper plugins here. So maybe I can make this 150. Let's see, save. This other one. 150. Save. Alright, gotta unlock these. Is there a line? There's no line. And if I go, let me see. If I go test message and test message. Damn, YouTube is kind of slow. But it's there. All right, not too bad. Okay, we're good. We're all ready to go. Learning more Rust. And let me check the title. Is the title good? Yeah, it looks pretty good. Sorry, I'm messing around with the stream a bit. Okay, looks pretty good. Uh-huh, I know what's happening here. Okay, there's a bit of YouTube latency, but I can't fix it without stopping. Okay, that's fine. We'll figure that out next time. All right. So, learning Rust. Let's see where we leave off. Oh my god, we did structs last time. I think I was pretty happy with structs. So, learning Rust by example book and the Rust book. Let me take a quick look at kinda what did we learn here. Okay, this is accurate. So the Rust programmers, Klabnik getting started, programming guessing game. I guess let me read this because I kind of noticed this yesterday, and I realized we didn't actually read this. See, like we didn't read about Rust keywords, for example. You cannot use these words as names of variables or functions. I mean, this is pretty common for any programming language. But still, probably want to keep those in mind. Most secure systems using to various tasks. There are a few have no current functionality or reserved. Interesting. List of keywords. Maybe this is good to have. Oh yeah, this is good to keep in mind. As primitive casting. Async, await, break, exit the loop immediately. Cons, define constant. We don't know what those are. Continue, create, din. Else, if, let, enum, extern, false, boolean false, fn function, for loop, If branch based on the results of a conditional expression. Implement inherent or trait functionality. For in, okay. Let, bind the variable. Loop match, mod, move, mutability and references, raw pointers, or pattern bindings. Public, ref, return. Self, we saw this last time. It's the type alias for the type, the capital self. The lower self is the method, subject, or current module. Interesting. I'm not at modules yet. Static, struct, define structure, super. Super, but it's modules. It's not object oriented. Okay. Trait, impl trait, right? Because that's what we saw last time. True, boolean true, type union, unsafe. Never want to use unsafe. Use, where, while. Okay, pretty good. Now let's go back to common programming concepts. So variables and mutability. This we kind of know a lot about this already. But do we? Storing values with variables. By default, variables are immutable. Good, a nice reminder. This is one of many nudges Rust gives you the right code, and we're taking that in ease concurs. However, you still have the option to make your variables mutable. Let's explore how and why Rust encourages you to favor immutability, and why sometimes you may want to opt out. This is good to keep in mind. So Rust encourages immutable. Once his value is bound to a name, you can't change that value. Okay, so good. We gotta get used to these terms more. To illustrate this, generate a new project called variables in your project by using cargo new variables. I'm not gonna do that. Oh yeah, the Rust playground is something else we need. I'm gonna get this ready too, so we can mess around here actually. All right, with the main, and that's it. Let's see what they want us to do. In your variables, open main and replace its code. Okay, so obviously this does not work. Yeah, I mean we're already too advanced for this. Cannot assign twice to immutable variables. Assign to variable. Gotta get used to the language. It's important that we get compile time errors. We attempt to change a value that's designated as immutable because this very situation can lead to bugs. Okay, for one part, the cause of this kind of bug can be difficult to track down, but mutability can be very useful. So then we make immutable and it works. Declaring constants. Okay, I think we read this. Okay, so you aren't allowed to use mute with constants. Aren't just immutable, they're always mutable. Okay, I remember we read this. Okay, we read this. Data types. Okay. Okay, good. Control flow, did we read this? Yes, we did. Yes. We never used the loop, though. But maybe we'll, let's play around with this one, for example. I don't think we went through the loop code. So the result is 20, right? So let mute counter is 0. Result is the expression coming from the loop. I mean, no, this whole thing is an expression. No, this whole thing is an expression. Semicolon is there. Break. I have not seen this syntax. Break space back. So this is break return. Returning it is. One of the uses is to retry an operation you might fail, such as checking whether a thread has completed its job. We also need out of the loop. To do this, you can add the value we want returned after the break expression. Okay, so it is some syntactical sugar here. Interesting. So, because this doesn't work, right? Right, because loop has its own return type probably. It's not just... So let's do this the crude way then. So I could have done a for I in 0 to 1000. And I could have done this. And this is a return out of the for. And then it's a return out of the... No, it's still a break. If I were to guess. Okay, I cannot use break in a for loop. Okay, I'm messing it up. Okay, never mind. So it's only, break is only for a loop. Well, if we're on the rabbit hole, let's go in the rabbit hole then. So can you break and return a for loop in Rust? Oh, it's return. Aha. Okay, so it is what I thought. So let's try again. So we have an expression, and for gives us the expression, and then we return. If counter is 10, we return counter times 2. Interesting. Why? 4? No, but no. Okay. Aha. So this is it. Break. And after the 4, counter times 2. Good. This is good practice. Good. Okay, so you can just break a for loop. You cannot return a value out of it, but that's not true for loop, apparently. Which is an interesting choice. Good to remember. Okay. So how do I get this bot out of here? Hang on. On link. Insurance quick dashboard chatbot. Hang on, timers. What the heck is this? Oh, come on, dude. Okay, well, I don't have to get rid of this stream elements bot now, but it's fine, I guess. Whatever. All right. Okay, so returning values from loops, pretty basic. Before the loop, then we declare variable name result. Yes, through the value returned from the loop expression. On every iteration, we add one, blah, blah, blah. You can also return from inside. Well, break return those exits the current function. Well, we definitely have not seen this one. Disambiguating with loop. If you have loops within loops, break and continue apply to the innermost loop at that point. That sounds about right. You can optionally specify a loop label on the loop that you can use with break. Specify that those keys apply to a label looped instead of the innermost loop. Oh, this is a big one. Okay, let me see. So what is happening here? So we have a mutable counter, and we have a label whose syntax is eek. Single quote name. So outer, I guess counting up. So print line count, let mu remaining 10. Then you print the remaining. If the remaining is 9, you break. If the count is, you break and you give the count plus 1. If the count is 2, you break the outermost one. Otherwise, you dock a remaining. Interesting. So then, yeah, we have count 0. We count down 10, 9, we get a point. 10, 9, get a point. 10. It's not 9, but it is 2. We exit everything. I see. So then this is counting down loop. And obviously this is trivial here. This won't do anything, right? It will not. And so what about this one? If the count is 1, I cannot break inwards, right? This is gonna be a compiler error. Loop is not defined in the scope or something? Yep, okay. Because I'm not inside here. Okay. So I can only break my current chain, not my children. I mean, which makes sense, obviously. All right. Okay. Interesting. Streamlining conditional loops with while. Interesting. We never encountered while either. Program will often need to evaluate a condition. While the condition is true. Okay, so it's just while. Lift off. 3, 2, 1. Lift off, right? 3, 2, 1. Yeah. Yep. Okay. A program, well, it's going to cover this pattern is so common that Rust has a built-in called the while loop. Okay. If you use loop, if, else, and break, and it's clearer. So let's re-implement this with loop then. Okay, so what do? Print ln number. So we do loop number minus 1. And let's give it a name, countdown. If number is 0, break countdown. So we should get 3, 2, 1 liftoff. Yes, okay. Not the worst syntax here, but yeah, of course, obviously we know what while is, so not the worst syntax here though, to be honest. Not the worst syntax. Looping through a collection with 4. While index. The code counts up. Okay, so we have an array. Okay, an array with a size known at compile time, as opposed to a vec. And we can walk with an index, or we can use the fancy for Or we can directly iterate over elements, very Pythonic. For element in A, we run this code. More important, we've now increased the safety of the code, chance the bugs going from beyond the end array. Okay, so we decrease the chance of runtime panics. Machine code generated from for loops can be more efficient as well because the index doesn't need compared to the length. Using the for loop, the safety and seismics and only use construct or generation score. Most rustaceans would use a for loop range. Even in situations where you want to code, as in the countdown example. I mean, of course, yeah. So you count in reverse. I did not know about the rev. This is a slice from 1 to 4 Pythonic, so non-inclusive in the end. What was the syntax? Was it like this? No. Like not? Whoops. Rust include and value in slice syntax. Oh, equals. I remember it now. Okay, so from 1 all the way down to 4 in reverse. 4, 3, 2, 1. Okay. You made it. This was a sizable chapter. You learn about variable, scalar, and compound data types, convert temperatures. To practice with the constants, try building programs to do the following. We can do the Fibonacci number. So let's generate the Fibonacci number. So let's see. Well, shit. Without recursive functions, right? So let's do it the crude way. So let number equals n equals the 5th Fibonacci number, and we have let mute past. Does this work in Rust? It doesn't work in Rust. Interesting. So mute past, mute current does work. 0, 0. Oh. Double tuple? Okay. All right. So we have n. And it's 1, 1. So what is the Fibonacci thing? It is for I in so n times we apply the following. Well, that th doesn't really work, but sure. Because it could be the 3rd Fibonacci number. It's RD. N. And we're going to store it in current. So then what we want to do is current is equal to current plus past. Damn, do I really need a 3rd one? So I guess I do need a 3rd one. Swap. Swap is current. Past is swap. I think this is right? So the 4th Fibonacci number is 8, 13. 21, 6th. Why am I getting all these so okay, so unnecessary parentheses, okay. Unused variable I. So what the heck do I do? Like for nothing? This work? Yes, it does work. Okay, so for anonymous loop variable in n. So I can leave this uninitialized? Oh shit, this is still memory safe. Huh. Very curious. (21 plus 13, 34). Okay, good. Can you leave Rust variable uninitialized? Yes, you can. Because they don't point at any value in Rust terms. You cannot read or use them until they are, so you can declare. Interesting, very interesting. So this is a U32 and type inference still works here. I prefer U32s. Oh, I don't know this syntax. How to declare, to initialize two Rust variables at once. Okay, but how do I type annotate them? How to initialize and type annotate two variables at once? Oh, I see. It's tuple. Okay, this is good. I like this. Okay, so let the tuple, which is typed as the tuple, be equal to the pattern given by the tuple. Good. Pretty good. I panicked, I overflowed on the U32 add, so I guess if I can do U64 here, or what? Probably won't overflow. Well, probably will overflow. Alright, we're just messing around now, so... Okay, pretty good. All right, pretty good. So let's go back to, okay, summary. We made it past control. Okay, ownership we did last time. Kind of not going to read this again. Each value in Rust has, maybe we will read it a bit again. Each value in Rust has an owner. There can only be one owner at a time. When the owner goes out of scope, the value is dropped. Okay, so we know this. The string type, they took it a bit farther away. Using structs, we saw it last time. Enums and pair matching. Oh yeah, yeah. Thanks for joining. It's interesting. I never took classes like that, so I just started Rust a few streams ago. But I kind of do know a bit already. But it is pretty nice. I liked. I come from Python, so then I started typing my Python code like 1 year ago, and I really like it these days. And then this seems pretty natural. We just did that last stream, the ownership. Yeah, I was pretty. There's some nice. I'm also doing the rustlings exercises. So yeah, we got a bit tricked last time. So last time we did ownership and structs. Structs are a bit easier, it seemed like. Defining, yeah, we looked at this last time. I'm not gonna go over it again. It's pretty basic. We were playing around with the playground. Yeah, with the rectangle, implement a trait for a struct, the self thing, mutable self, or reference to self. Yeah, so basically it seems like from last time, like the lesson was just use references almost always. Like, because otherwise you're going to drop your own value and you're going to scam yourself, right? It's not clear to me yet why you wouldn't always use a reference, but we'll see. There's definitely examples somewhere. Good, so let me do this. Let me restart the rustling. So if I type rustlings, it'll take us to... Yes, we finished the struct, so I hit next. Okay, so it takes us to enums. Good. Enums. Rust allows you to define types called enums, which enumerate possible values. Enums are a feature in many languages, but capabilities different in each. Oh, look, it's your favorite old camel. Rust enums are most similar to... See, this is... I'm not familiar with this stuff. Algebraic data types in functional languages. I only know enums from C. And I'm guessing this has nothing to do with it. Because enums in C are only integers. Or just a plain list of values. Maybe I'm wrong though. Maybe that is what an algebraic data type is. Which makes these run different code for different values of an enumeration. Sounds like a lot of runtime checking, but that's probably not what they want you to do in these functional languages. Okay, so let's go to the book then. Enums and pattern matching. Enumerations also, oh shit, sorry, referred to as enums. What did I do here? Oh, sorry. Okay. Enums allow you to define a type by enumerating. Define a type. Okay, it's definitely... Okay, so define a type by enumerating its possible variants. First, we'll define an enum to show how... Use enum to show how an enum can encode meaning along with data. Next, we'll store a particular use for an option. Which I think I've seen this. Then we'll look at how pattern matching and the match makes these are in different code. We'll cover how the if-let construct, concise idiom available to handle. Interesting. Well, this sounds kind of basic. Maybe it's not what I thought it was, or where structs give you a way of grouping. Dude, if this mouse click would work, okay. Where structs give you a way of grouping together related fields and data, like a rectangle with its width and height, enums give you a way of saying a value is one of a possible set of values. Remember to say that rectangle is one of a possible shapes. That also includes circle and triangle. Because an enum. Let's look at a situation where we're going to express in code. Oh, sorry, let me go here, okay. So structs, okay. So let's look at a situation where we might want to express in code and see why enums are useful and more appropriate than structs. Say we need to work with IP. Currently, two major stands of version of blah, blah, blah. Because these are only possibilities, we can enumerate all possibilities. Could be... Okay, this is way too basic. I mean, what the heck is happening here? So, V4, V6. Okay, so I'm guessing these are types now. They're not like scalars. They're not, they don't store values, right? They're just like actual new types we invented. So we can have a singable mute. Yes. I think so. Yeah, that is true. Yes, it can have a... Well, here's the interesting thing that we learned yesterday. Yes, I think there's a... It's a bit more subtle. Actually, even I discovered this yesterday, but there is a... Well, no, you're right. I think the key in your message is add a time, because you can do stuff like let mute x for... Well, no, actually we need to do... Like we can do a vec 1, 2, 3, and then we can say let s it's a reference to x, and then I can do s push 1, and I can take another one, y, and I can push a 2, and this should work as expected. Okay, I need the debug print. That's good. Cannot borrow as it is. All right, sorry. So it's a mutable reference like this. Actually, so I don't need these guys to be mutable. Okay, so yeah, this works. So there are 2 mutable references here, but they are in time, right? If I do this, it's not gonna work because they now live simultaneously. Yeah, so they have to be separated like causally, which kind of makes sense, right? Like you need to finish all your business with S. You can do other stuff here with S, like push 23. But you can't interleave them. You can't do this here. Yeah, this is not going to work. So it kind of forces you to write the code causally, right? So yeah, a single mutable reference at a time. You can still have 2 in the same program, but like one after the other, which is pretty interesting. It kind of simplifies programming a bit. And it's even the same, it's not even mutable. Like I cannot even I can't do this. I cannot even interleave. As long as I have a mutable, it completely blocks that variable, right? I can't even get another reference to it. Like I can't even get an immutable because I don't have any guarantees on what the state is. Oh, and then of course this line doesn't work. But my point was, wait a second, am I messing it up or? No, I'm not messing it up, yeah. So even if I don't try to touch X through Y, I still can't do this, even though this is not mutable. So this was pretty interesting. I think this is the hardest part to get used to, like, a mutable blocks even a non-mutable reference, basically. It completely blocks the value behind the variable, which kind of makes sense, though. It has to be like that for safety. All right, so the enum looks pretty easy. So I get an enum with 2. Okay. And then I can just create instances like this. And this doesn't do anything, I guess. So what the heck are these? What are these? Let me print these. So if I print line, four. Oh, I need to derive debug on this because good catch. So it's like the literal type v4. It's not even like C where it's 0, 1 by default. It's so there's no value behind this. It's just a pure type then. Yeah, it's a custom data type, but even the instances of it. Note that variants are namespaced under its identifier. We use a double colon. This is used because now both values. What the heck kind of values are this though? This is not a string. I guess a type is a value too. Okay, so they serve as type. So they are valid type. They are valid IP. I mean, IP address kind is the type, I see, and these are the types for the value. So then I can call it with instances. Thinking more about, at the moment we don't have a way to store data. We don't know what kind. It's going to be learn about structs. You might need to attack it for structs. kind and address. Okay, so let's see. We can also add a struct here. And we can let home and so the struct IP address. Yeah, this is pretty basic, right? So this is an instance of the struct IP address as two fields. Again, kind has this magical value v4, which I guess is not an integer or it's something. It's just literally a identifier called v4. Strings. And again, when I print this, I guess I need to derive debug here too. I'm probably gonna see. Yeah, so kind v4. Don't really get what this is. It's I wonder what it is behind the scenes. Is it like an integer or it's kind of like a literal? Here we've defined the struct IP address that has two fields, a kind field as and an address field. We have two instances of this struct. The first is home and it has the value v4 as its kind. The second is loopback. Oh shit, you can represent the same concept using just an enum. Rather than an enum inside the struct, we can put data. Okay. So rather than, okay, so this is a container thing. And it's empty right now here. Which I guess must have some backing storage, but you can put data behind it. So now v4 is a container that it's a container of type v4 with a string and a container of type v6 with a string. And I can directly get, we attach data to each variant of the enum directly. So there is no need for an extra struct. Here it's also easier to see another detail of how enums work. The name of each enum variant also becomes a function that constructs an instance. Okay, so it's like a struct constructor basically. IP is a function that takes a string and returns. Well, can we assign two data fields? Yes, we can. Okay. There's another advantage to using an enum. Each variant can have different types and amounts of data. Okay, so these are containers. Yeah, version 4 IP addresses will always have 4 U into U8s. Okay, so I can have some hybrid things here. Interesting. So it's IP address. And there was IP address v4. Okay, so 23, 34 for 12. And the v6 needs a string from hello. Let me see how these look like. Loop back. Yeah, so it shows you the whole container. v6 hello, I see. Okay. We've shown several ways to define data structures to store version 4 and version 6 IP addresses. Yes, we have. Okay. However, wanting to store IP addresses and encode. What? What is happening here? I now put the backing struct inside each. Oh, there is an enum called IP address. Oh. Not sure what the heck is going on here. You can put any kind of data inside an enum. Sure, strings, numeric types, or structs. Obviously, you can put a struct in here. You can even include another enum. Okay, maybe we can mess around with this a bit. Also, standard library types are not much more complicated. Okay, know that even though standard library contains, we can still create and use your own definition. Because we haven't brought the standard libraries into scope. We'll talk more bring times from chapter 7. Another example of an enum. This one has a wide variety of types. Okay, all right, this I like. So it has 4 containers, or 4 variants, I guess. Quit, move, write, change color. Quit is empty, has no backing data. So let me do 4 messages then, right? So I can do let quit will be message quit and nothing else. There's nothing else you can do. All quit messages are the same. Move. Oh shit, move is a restricted keyword in Rust. So move message. Move. I don't know the syntax. Why is it accolade? Like this is a struct here. So I do X is 1, Y is 4. I'm just guessing. Quit MSG. Move MSG. No. So it's just 1, 4. Oh, I see. Okay, well, never mind. I don't know the syntax, so we'll learn now. So, defining an enum. Okay, so yes, I could have done this with structs, and this was an empty struct. So again, empty storage. But if we use different structs, each has its own type. We can use define a function to take any of these kind of messages. Aha, so I can implement a trait for message called call. No, a method, sorry, not a trait, a method. Impl message. Okay, but how the heck do I instantiate this? Is it gonna tell me? No way, it's not. Damn it. Rust enum init syntax. So the one with, so the color, so let write message. This one is easy because it's message write and has a backing string. So it'll be string from writing. This other one's also easy. Change message will be message change color backed by 3 integers like 256, 12, 2. How do I do the move though? The compiler says to do it like this. X4 Y7. It is like that. Okay. Kind of weird syntax, to be honest. I don't like this. Seriously, like this is the syntax. Okay, yeah, so I have 4 messages now, and they're all one of the 4 variants. Quit message, move message, write message, change message. These are all intuitive to me, except for this beast. What the heck? Like, I have to actually do it. So it has an anonymous struct as backing storage. Would I not have defined the struct here? I guess not. Because I'm going to implement a method for this now, probably. That's why. Yeah, so... Yeah, the only odd one out is this syntax for me, but it's fine. Okay. There's almost similarity between enums. Just verify methods. So implement message, right? The body would use self to get the value. In this example, we create a variable m that has the value message right, hello. And this is what self will be in the body. Okay, but they're just gonna leave it here, I guess. So let me, how do I specialize it then? Implement message, call. So now I have a reference, returns nothing. So what do I do here? If self is quit, I need a match, right? Probably. Which I think we'll learn soon. Okay, they want us to go through the option, which is another enum defined by the standard library. Expressing inconsistency, the compiler can check whether you handle all the cases. This functionality can prevent bugs that are extremely common. Programming languages are not in terms of which features you include, but the features you exclude are important too. Rust doesn't have the null feature that many other languages have. Null is a value that means there is no value there. In languages with null, variables can always be in one or two states. And some random dude had this to say. I call it my $1 billion mistake. Oh, thanks for the Twitch follow. Appreciate it. Just learning a bit of Rust here, day 3. So feel free to stop by, lurk, or whatever, or chat. So the option enum. And this was Tony Hoare. Okay. At the time I was designing my first comprehensive type system for references. I couldn't resist temptation to point a null. Okay, sure. Let's not go into way too many details here. The problem with null value is that if you try to use a null value as a not null, you get an error. Hey, it's pretty good. It's day number 3. We did the borrow checker last time. We did a bunch of rustlings. I'm also going to switch to rustlings at some point. Actually, this is why I'm looking at enums, because I'm doing these exercises one by one. I think it's good. It's definitely easier for me. I got used to syntax. It only took like 3 days, which is pretty wild. But now at least I can read Rust code and I can understand, and I can write stuff like this, basic stuff. So not too bad. But the borrow checking was the first hard part last time. So we'll see if I made a few mistakes. We'll see if I'll correct them. So not too bad overall, can't complain. Let's see, so yeah, progress is not too bad, can't complain too much. Yeah, the Rust, the reference stuff is, it's the trickier part, but I think I kind of got it. It's just basically it seems to force you to like just pass references all the time, and at most one. Like it really seems to force you to program like that. Otherwise, you can have multiple references, but they have to be ordered in time anyway. So, and then there's the whole reference counting stuff, which I didn't get to, but I vaguely know about. The problem with null value, okay, so the problem isn't really the concept. As such, Rust does not have nulls, but it does have an enum that can encode the concept of value being present or absent. Option around the type. Defined by the standard library. Defined by the standard library. Is there anything useful here? Returns true if the option is a sum value. Okay, so we can play around with this a bit. So let's see. Let me just comment all these enums. So this is an option, U32, sum 2. Oh shit, sorry, not the impl. The impl is incomplete. And why is this not just 2? So it has to be sum 2. What the heck is sum then? Sum in Rust. It's just a container types that indicates there is IC. Oh, I see. It's one of the two variants. Oh, okay. I'm so dumb. Okay, so it's sum. All right. Of course it has to be like this because the enum says it's either sum, okay, and then I'm guessing the other one none also works. Okay. And the T must match, so sum 2.1 will not work. Yeah, because it's a mismatch type. So this is actually TU32 to be more precise, but it is 2. Okay, and I have a bunch of methods here. Is sum, is none, which are basics. Okay, I feel like this is going way too, yeah, there's 5 million methods here, of course. So this is the important one, unwrap, because this is how you get consuming the self app, because this function may panic. So this is how you get the true value behind the storage. Oh, and unwrap or is the safe version, like it's the non-panicking version. Unwrap or else, or computes it from a closure. So let's see. So if I do print line X unwrap or there's nothing. And then if I do the same for Y, I should see a 2 and a nothing. All right, I need to unwrap to the same backing type then. Interesting. I can't unwrap to something arbitrary, right? Because it says here unwrap or the default has to be the same type. Duh. Interesting. So I guess 999, right? Hey, thanks for joining. Messing around with enums. Okay, I see. So option is an enum with 2 variants, none or some. Yeah, we have somebody else's here talking about I was telling people about the experience yesterday with the borrow checking. As mutable. All right, so then we can unwrap or we can return a default. Not much. I spent like half an hour. No, you didn't lose much. I spent half an hour. I think I read one of these sections which I somehow missed because of the rustling. So I think it was control flow, and they had a loop section which I had completely missed. Yeah, so I played with this for like half an hour. Because there is this syntax for naming loops, which I had not seen before, and breaking from the innermost loop. So there was some finicky here, and then that's it. I started enums. Let me go back to where I was. So okay, I'm still on chapter. Okay, so I'm in the option enum. So okay, this is where I was left off. Are you talking about the enums or the loop things? The breaks, yeah, breaks I know, but it's useful for me to see the syntax because it was a weirder syntax. It's like involves some sort of quote symbol. Oh, break-wise you meant? Yeah. Break is obviously Pythonic too, but you can't name what you break in Python unless, am I tripping? Let's see. Can you break 2 levels higher in Python? Can you break? I don't think you can do this in Python. No, you can't. So this is actually pretty strong for Rust, because you can break from the innermost. If in Python it gets pretty ugly because you have to keep a flag or something or whatever. But Rust has this trick where you can break the outermost loop from somewhere deeper in, which was pretty nice to see. All right, let's see what's going on here. So the option is usually, you don't need to bring in the scope. Okay, so option is like super baked in the standard library. Like we don't even need to import it. Okay, obviously, because this code just worked. So you can use some and none. The option T, oh, I see. And some and none are so special in Rust that you don't even need. Oh, right, because I didn't even do. Actually, the correct syntax is option. Wait, this works then too? It does. Okay, so that's the correct full syntax. The type syntax. Okay, so this is important. The angle bracket T is a feature of Rust we haven't talked about yet. It's a generic type parameter, and we'll cover generics. For now, all you need to know is that T means. So I guess it glues it to a type. Yeah, so it's I don't know what the prelude is though, by the way, but I guess that is some sort of code that always runs. Okay, so it's a collection of names that are automatically brought into scope in every module. And I guess we get this guaranteed in the Rust. Oh, it's the standard library prelude. Okay, interesting. Yeah. Interesting. So it's good to know we have some things available. And is there an exhaustive list of all the things I have available? Probably, right? No standard not applied, Rust 2024. Like, what is it? Oh, it's all this stuff. Interesting. Oh, yeah, like drop, copy. Oh, right, because even yesterday we derived the trait copy without bringing it into prelude. So it was box, vec, clone, default, result, option. Here it is. Self sum none. Okay, it's not that many to be honest. So I think these are good to memorize actually. Because string, obviously, because we use string, vec, toString, result, option, iterator, extend into iterator. Maybe this is good for later. I may want to go through all of these one at a time. Size of, align of, to owned, fn mute, fn once, copy send. Okay, not that many. Interesting. Because it makes sense. You don't want to crowd this, right? Because you just increase the risk of programmers aliasing them. For now, you need to know the type. Okay, generics. Each concrete type makes the overall option T have a different type. Okay, so option I32 is different than option I64. Which makes sense. You can't assign a sum. Some example of using option is to hold number types and chart types. The type of sum number is option 32. Type of sum chart, which is a different type. Rust can infer these types. Okay, so the same story with type inference, which I don't like. None, of course, doesn't work, so you have to tell it explicitly what it is. When we have a sum value, we know the value is present, the value is held within. When we have a num sum. In short, because option T, the compiler won't let us use an option T. Yeah, so this doesn't work, but I think I know how to fix this because I was looking at the methods. So it should be with unwrap then, all right? So if I do let x, y, I can unwrap y to get the true value or with a default of 0. So now this should work. And it works even with none now, right? I can sum x plus none, but it's actually x plus 0. Okay, pretty good. Can't complain too much about this. We have a sum, in short, because option T, yes, for example, is called okay. Intents. In effect, this error message doesn't say how to add, of course. We have a value, the compiler is sure. When we have option, do we have to worry about the possibility of something bad happening? Then the compiler makes sure handle. In other words, you have to convert an option T to a T. Okay. Which is what I did with the unwrap. Assuming that something isn't, yeah, it'll make the risk of incorrectly assuming a not null is confident in your code. In order to have value that can possibly be null, you must explicitly opt in by making the type option T. When you use that value, you're required to explicitly handle the case. You can safely. So how do you get the T value out of sum? Okay, so yeah, this is the documentation that I found. So you can get it with many things. You can get it, well, no, I guess mutable. Is some, is none. There's a, yeah, exactly. This is what I'm looking at. There's a lot of ways to extract it, right? You can expect it and you can panic if it's none. You can unwrap it, but also panic. This is the one I like. You can unwrap or with a default, which kind of makes sense. Unwrap or else. This one I don't understand yet. What is, I don't understand what this. Oh, it's another type? No, it's a function type. Oh, I see. So unwrap, exactly. So this, oh yeah, because we talked about this yesterday. This is a function signature type where it's a function that returns the T, the right T. And it also must take no arguments. What is fn1 is special? The version of a call operator takes a by-value receiver. Instances can be called, but not even called. It's like a... Okay. Interesting. So it must be a closure without arguments. It must directly return something. Which kind of makes sense. I guess you can't... You have to bake everything in the function body. Okay, so yeah, this is a closure that returns double the value if it's... I see, so 2 times k. So it returns 20 basically. This is a function that takes ownership of given parameters. Okay, and this is an fn1 without arguments, so it must be without args here. Unwrap. What the heck is or default? What's the difference between or with a default value? Unwrap or default returns the contained sum. Oh, wait, there's default values? Oh, because you can implement this to be custom for a type. Oh, I see. So you can make it your own type. Like for your custom struct, you can have a default and then you call this and you don't have to specify it every time. It just calls into the default you implement once. Damn, this one seems good to know, yeah. The default trait, exactly. Okay, I'm pretty excited about traits now. I see. Well, I guess they call it a method. Is it a trait or a method? Oh, the capital default is the trait. Default is the method, the small one. Oh, I see. So it's a required method. Yeah, okay. So the trait default has a method, little default. And that's it, just one. I guess you can do others, but why would you do that? Okay, unwrap unchecked. This one is unsafe. We're not touching that. Map, inspect. What, inspect is just a peek at it? Or I guess it, oh, I see. It allows you to call a function, but doesn't peel it off. It gives you back the option as it is. So it's like it's a probing function, right? You call a probing function and it's a, you give a reference to it. This one's interesting too. So you can, yeah, it's anything. Yeah, exactly. Good for debug or like checking things about the what's in there, but without trying to unwrap it. Map or else. Okay, so these are all function pointer stuff where, oh my god, you can pass 3 of these. Wait, so there's another type U here? Like you don't have to go to T? Computes the default function result or applies a different function to the contained value. So it's D or F. Why did they switch to U here? Is this a typo? They should have put T here? Or is it not the same T as... like this T... Interesting, yeah. I guess they switched to U at some point. No, but there is a difference here because you swap the type. So T is still, even though it's not present here, you go from T to U. So I guess this means you can arbitrarily, I guess this allows you to arbitrarily change the type, right? From, like you don't have to unwrap to a T, you can just unwrap to a U, either through a function or through a default here. Which kind of makes sense, like, although it is a bit weird, but sure. Yeah, because F is a converter basically from T to U, and D is the default that gives you U. Same story. Okay, or transforms the option into a result. I feel like I've seen this result. This one is pretty... It's another enum. So now we know what enums are. So it's either okay or an error. I see. So this one gives you two variants and they have different data types, which is fine. It's either a T. Yeah, result is a very basic one, right? Yeah. Which is kind of similar to this option, except it hasn't... It's more abstracted. Transforms the option to a result, mapping some to okay and none to error. Okay, yeah. So if there is something in there, you'll get an okay. And then I'm guessing you can unwrap this one the same way. Yeah. So they seem pretty similar. Okay, or else as the ref. Converts to option T to option. I don't know what target is. This is something else. I have not seen target before. I guess it's a force dereference. Okay, we'll see this later. It's probably too much for now. Oh, iter. You can iterate over the possibly contained value. But what happens if it's none then? Oh, you get the none back. Oh, this one's pretty interesting. So hey, thanks for joining on YouTube. Not much, just learning some Rust here. It's the third day of learning Rust. It's going pretty well. Iter. It gives you a reference though. Yeah, this I don't know about the lifetime, but I'm trying to understand why does it give me a sum. So if I have a 4 wrapped in sum and I iterate, the next value is, oh, Rust is a low-level programming language, kind of like a better C or something. Let's put it that way. So although it does smell a lot like Python, so it doesn't look too bad. I'm getting used to syntax, so that's pretty good. It's not the video game Rust. Very important to note that. Yes, Rust, not the video game. It's a programming language. Yeah. Iter returns references to the... Okay, so that's why. It's because I guess... Where can I tell this from? Oh, I see. It's capital iter. Okay, so it's iterator over a reference to the sum variant. Okay. Let's see more. And returns none if option is none. Otherwise returns opt. Oh, you can swap to another option. Oh, wow. It's like a logical swap here. So if it's none, otherwise return the other one. Interesting. So X is a sum from the need into. Okay. So X is sum and then Y is none, and X and Y. Oh, it's actually logical and between them. Okay. Yeah, this does seem pretty wild. Like you can do logicals. Filter sounds important. Again, it's a function pointer that takes a reference, returns a bool. Okay, so you can apply Boolean filters. So these are all just to do all this stuff without unpacking, basically, like to do it implicitly and to give you a none. So you don't have to implement the check yourself, right? If it's none every time, it just allows you to apply different maps or functions. Okay, I think I'm ready to go back. Okay, let's not go too deep in the rabbit hole. So you have to convert an option T to a T. Now, we've seen many ways to do this. Before you can perform T operations, generally this helps catch on, so assuming something wrong. A lemming makes you confident in your code. That's good to know. That, yeah, that makes sense that they encourage you to use, like, iterators, yeah, instead of manual code. What degree do you have? Oh, I have a PhD degree I got a few years ago, but it's not in computer science, so I was never a programmer. I'm not quite the programmer type. I only come from Python world. We are kind of a third of the way into Enums. Thanks for joining. I went deep in the rabbit hole. I started reading a bunch of methods for the option type, which is pretty good though. I can see why it's useful. Then I also messed around with some basic enums. which seems like, okay, now that you guys are here, so the way I think about this, so they teach you this example, like a message with 4 variants. These are like zero size. This is a zero size type, right? Like all these quit, move, the types themselves are zero. They're just like thin containers around data. Like, and in this case, actually, what I don't get is there backing storage for this? Like if I have these 4 messages, right? Yeah, I would guess so. This variable quit message, which is just message quit, it has nothing behind it. Like when I print it, it just gives me a type, but it's like there's no integer or nothing backing this, right? This is pure type, pure algebraic type or something. It must be. These other ones, they have real data behind them. I would guess this is just a type. But yeah, then I'm assuming this is useful for impulse, for a method on the type, but we'll get to that. So let's see. So first, options that we can extract, if it's 0, 0, 0, then it's none because the pointer can't be null. Oh, but I'm asking even more basic, like even just an enum, like stuff. 1, 2, right? And then if I create let stuff, like what is this? This is do I have a syntax error? Oh yeah, double colon, sorry. So stuff is a variable that points to no value. Let me speak in Rust language, right? There is no value. Or is this, does this count as a value? No, it's not a unique value, right? Because then if I do other stuff, what? So I have 2 values now? Yeah, we'll try to fit. So it is the value, it's of type stuff. Interesting. So what is the value in the, is abstracted away as an, oh, it is an integer. I would have guessed, yeah, so it's just 1. I guess it defaults to an integer, right? It's a type whose value is its own type. Yes, it's yeah, that it definitely seems like a very thin, like a 0, well, not a 0 size type, but it's a type. Yeah, it's a pure type basically. But I'm guessing these are, well, okay, assuming we do something with them, right? So let's say I do something with them. Because now if I print them, the compiler won't optimize them away. Oh yeah, because I have to derive the debug. Okay, so now we know for sure they're not optimized, but they both have sort of the same value, but I wonder if in memory these are different values, which maybe this is where the optimization comes in. Like, you don't need 2 values here. They both point to the same fundamental type here. Yeah, they are not, right? Because it's a pure type. So you just need like 1 integer. The debug is printing as 1, but under the hood it's still binary data. Okay, so there is underlying data, but is it the same between these 2? I would guess yes, because the compiler optimizes it. You don't need 2 different underlying data in this case, just for this one. For these other guys, of course you need them, right? Tag union Rust. The compiler knows they point to the same data. Yes, I would have guessed so. In this case, they must. There's no point in having. Now, of course, if I add an I32, then the story changes, right? Because there is a real I32 there. Okay, so this is like a pure type. Okay, well that's good to understand. Okay, let's go back to, because we're. You have to convert an option T, eliminating the risk on option T. Use that value. You're required to explicitly handle the case when the value is null. Ever defines the type of case. So how do you get the T? Okay, we saw this. In general, use an from T, you have some T, and this code allows you to. Okay, so we're basically going to use unwrap or something. And then it goes to the match control flow, which is a bit weird ordering. As long as enum elements are trivial, they will refer to the same value. Okay, yeah. And I guess a pure type counts as trivial, yeah. Like these are all trivial now, all right? Penny, these are pure types, right? A coin is one of 4 types. So there's 4 different values here, yeah. But then if I have 3 coins that are all pennies, they both point to the same type or the same backing data. Or they will refer to the same value. Rust has a powerful control flow called match. I would have guessed it's like a U size probably, right? Or is it really U8? Or I would have guessed it's U size or U32, whatever that is by default. Rust has an oh, it tries to. Oh, I see. It's even smarter than that. You're right, because you only need like 4 of these. So yeah, it makes sense. You need U8. Yep. If there were 280, yep, you go to U16 and then U32. I see. Okay, good. Rust has power called match. Patterns can be made up of literal. Chapter 19. Okay, the power of match concept expressed. Think of a match as being like a coin sorting machine. Coins slide down the track. Variously sized holes around it. Each coin falls through the first hole that it fits into. Okay, what the heck. So let me take this then. So coins and the function. You want advice? What do I do after 12? The grade, I'm guessing. You should go to school. Yeah, you should get an education. That's, I don't know what to tell you, but yeah, not 100% sure about computer science. I never did it, but maybe one of the hardware engineering, like hardware engineering or something. Speaking of coins, we can write a function that takes an unknown in similar way determines which coin it is. Okay, so we've seen this when we're getting to if let and while let. We've seen if let. No, we already did the ifs. I mean, the thing is, so I'm still following rustlings, by the way. All this is because rustlings tells you to read enums. I'm not sure why they put the match here, to be honest. It is a bit confusing, but I guess they want to group the match with the enums. I feel like we've seen this. I've coded this already. Like, I'm gonna skip a bit. Patterns that bind to values. I swear I've seen this. Let's change from so quarter has a US state. Sure. Yeah. Yeah, it's showing you can just match a pattern. I mean, you can match pattern with an enum. Well, okay, so match coin. Yeah, because this is the value of coin. So it's more generally you match variables with values, right? It just so happens that in this case it's yeah, I think we've seen that too. Like you can match a pattern, right, directly. Like you can match on a tuple. I think we've done this, like even in the first day. State and data, ends up being so useful in storing state and data in enums containing other data. So let's see what they do here. So now we have a nested enum. It's a quarter that also has a state. Let's imagine a friend. Oh, so you can unwrap the state here. But this is not an option. It has, okay, so you can unwrap the state here directly. We can add a variable called state to parent that matches values. The state variable will bind to the value deconstruction, yeah, or binding, I guess. The state variable will bind to the value of that quarter state. Let me try this. Okay, this may be a good example. So let me see something then, if I get it right. So if I had tried to do... Well, actually, let me just... Okay, so let's do a coin. So we can say coin is coin quarter US state Alaska. I think I got this right. And if I let, of course, and let value is value in cents for the coin, and print line, the value of is coin value, and I need the debug prints probably because these are ugly. Well, not for the value is U8, and I also need derived debug. Uh-oh. Uh-oh. It's not a reference. Okay, Jesus Christ, okay. Right, it's not a reference, so I can't print it anymore because it just got dropped. So we know about borrow checking now. Interesting, and I can't do anything with it. So let's fix this then. Hang on. Now it's tricky. So I forgot this. So I need a reference to a coin. And that's it, right? I just pass the reference to the coin. Nice. Okay, so we understand borrow checking. So state quarter from... No, I'm not cloning stuff. That's not... I need to get used to the borrow checking and references, yeah. So state quarter from Alaska. So my question initially was, can I match on this now? State quarter. Let me see if this works. It doesn't work. So if I have a nested enum, I need to match. So I can no longer match on the base type. Like what? I need to do this, right? I need to match on... I need to put something there. Yeah, the type signature has changed, so you have to go through all of it. You can't just get away. That's what I wanted to find out. Yeah, you can't get away just with the... You have to match it exactly. Okay, so I guess it'll probably yell about unused here or something, yeah. Okay, this makes sense. So you always... Yep, core coordinates acting like a tuple. Coin quarter acting like a unit type. Coin quarter is acting like a tuple. Interesting. Coin quarter, the original one. I don't know what this is anymore. It's a tuple containing what? Like a state? And that's... No, quarter and the state? Or... Like it's a tuple between the... And it has the quarter... Nah, but quarter is no longer even a type, right? Or does it just... Okay, so it's a tuple only containing the state. Like this has completely... It's not even a thing anymore, just a quarter by itself. So it like gives way to the state, basically. Okay. Okay, now I feel like we're getting into... Actually, I kind of like this type-based design stuff, so I gotta pay attention here. All right, so if we were to call value, quarter is a variant. Okay, quarter is a variant, same as penny, just with data. So is there a way for me to test that it's just a quarter? I guess it is the match, right? Yeah. So you have to say that it's a quarter in a state in the match. You have to indeed fill. Yeah, exactly. That's what I want to know. You have to fill the quarter. There's no way to check if it's just a quarter, regardless of if it has like, maybe it has more stuff in here, but I don't care. Okay. And let me try something else. Because you can't have a quarter without its data. Yeah, I think I understand. Yep, that makes sense. So then if I also put a city, New York, or let's see, New York and Portland, and now I'm guessing I can make this a real tuple now. I mean, not that the, and if I put underscore here, does it capture both of them? Or do I need to put 2 underscores? Oh God, hang on, where's the debug? Aha, it wants 2 underscores, so you need to actually unwrap the tuple, right? What the heck, this is not the syntax though for 2 types? Oh, sorry, I'm not making the quarter right, duh, right? Because I need to make US city, Portland. So wait, it works with 2 underscores, but it doesn't work with 1? Okay, it doesn't. Okay, so you need to discard both of them separately. I was checking if, is there a way to get away with like all of them at the same time? What if I have like 7? I guess that's bad coding, so it's probably, you don't want to do that anyways. Yeah, no, I understand. You can't get them in pieces, but there's no special syntactical sugar like to get rid of all of them, like dot 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 or something. No, it's not. Yeah, I can. Obviously, you need the case where you split them in pieces. Yeah, but oh, is it dot dot? Wait, it is dot dot. Okay, this is what I was looking for. There you go. So you can... Okay, so this is the closest you'll get to a pure quarter match then. Because I don't even know what's in here. Like, I'm basically throwing all the type away, right? So actually, this is my original question, right? This is the closest you can get to matching just on a quarter. Regardless of what's in there. And this is the same as the slice notation. I guess it means something else here, though. Yeah, I just guessed it now because I thought it would be dots dot dot, but then the compiler tells you to use, it's a rest pattern, I guess. So there you go, we learned something new. Rest pattern. Oh yeah, it's we've seen this though, which matches 0 or more elements that haven't been matched. So actually I can probably do even better. I can do state and everything else, right? State quarter from state. Oh, come on, I have to do the thing. Okay. Yep, there we go. So you can actually drop. Yeah, we saw this. Like, I don't know what you would return here, but yeah, 127 or something default. But here's the interesting thing, though. Actually, why? Because the compiler tells you to not do that because it's on an enum, right? So actually, you don't need this here. Why? Are you talking about the arms of the enum? Because this makes sense to me. Like, there's no reason to do it for an enum. Because it is unreachable pattern. Let me go back now. Okay. So the option T match pattern. Okay, so now we also have an option. We're going to get the inner value in some case. We can also handle option T as we do with coin. Okay, so then you can return. Yeah, it'll work when. That's true, right? If I add a new one, yes, like a new coin, like a dollar coin or something. So if I add a dollar, this still works now, and the warning is gone. Yeah, that's a good suggestion. You can also add non-exhaustive. I haven't seen that one. Rust non-exhaustive. Attributes indicates that a type may have more. Oh, this seems useful too. Yeah, indicates that a type may have more fields or variants added in the future. Huh? Interesting. Oh, so then what? It cancels out the warning. Like if I do it this. No, it still yells about. Hey, thanks for joining the chat. Yeah, that's true, right? If you add the default and I put a dollar and then I forget to implement the arms. So what happens if I do this now? The compiler is gonna yell that I didn't cover the dollar arm? Yes, it does. Okay, so this seems useful then to catch at compile time, right? Because I don't even need to. But you would rather get the actual error like I did here, right? Because now it reminds you. So what happens if I do unimplemented? Does the compiler yell? Or no, that's a runtime thing, right? Yeah, it's a runtime thing. Okay, so I guess this will panic. Oh, because I added the attribute you're saying. So actually, even with this now the compiler yells. No, it doesn't though. Why? You're saying because of the non-exhaustive, Nate? It doesn't seem to do anything, right? Unfortunately. But I was expecting to be forced to handle it now with this attribute, but it doesn't seem to enforce it. Unless I typed it wrong or something, but I don't think so, because it would have not compiled. Still, I think I like the. So this seems to be just an indicator to a programmer, but yeah, okay. I like the compiler error the most. Like you get an instant error if you don't handle a type. Oh, I see. That attribute only applies for out of crate uses. Ah, interesting. Interesting. Yeah, maybe I had to read the docs better. Oh, yeah, you're right. Within the defining crate. Okay, there we go. So it doesn't do anything here. It's only for external users. Okay, I see. Okay, well, I don't want to do the whole cargo thing, so we'll defer that. All right, let's go back to the option T now. Well, we kind of looked already at the option methods. There's a ton of them, so I don't even know why you would do the manual match. Just do unwrap, right? I guess this is an option that returns an option. Again, I can already spot the borrow checker issues because they're, well, I guess they're returning ownership here. But 5 has been gone. Unwrap or panic. Yeah, so this one is just, yeah. But I found there is an unwrap or with a default. But I guess defaults are not good either. Because then, actually it's funny because default is basically the same as exhaustive matching in a way. Map to map a function with a closure thing. Okay, I'm a bit away from that, so let's see. So match, so this just, I mean, this is dumb. It takes the option and preserves the none, so it doesn't really specialize. It just moves it II plus 1. Sure, I guess it's a safe way of doing +1, and it makes the none pass through. Sure. Oh, this is pretty Pythonic though, because we do this in Python too. If an input is none, immediately return none. Otherwise, do some processing and return it. Well, if default. Yeah. Okay, so we're not at specialization yet. This is just processing an option, and it lets the none flow through, which makes sense. Matches on options are exhaustive. Or more, no, sorry, more generally, matches on enums are exhaustive. This is exactly what we talked about, right? Matches on enums should be exhaustive, which I agree with. Yeah, so this is obviously not gonna work. Okay, catch all and the underscore placeholder. Using enums, we can also take special actions for a few particular values. But for all other values, take... Okay, so this is the underscore. Imagine we're playing a game where if you roll 3 on a dice roll, your player doesn't move, but instead gets a fancy new hat. Sure. If you roll a 7, your player... Okay, and if you roll anything else, you do some... You move by something. Oh, wait, so you can name this too. Oh, okay. So this pattern I like better because then we can say... I can literally say other. And I can say panic. Don't know what to do with other. Well, I guess with this one, right? In this case. Yeah. And this future proofs it now, because if somebody comes and does dollar, but it must be if I derive debug in my enum and I match, I get a guaranteed derive, right? Because it comes from a coin. Yeah, it should, right? Yeah. Okay, so let me remove the non-exhaustive. Yeah. So now if I try to do a dollar, yeah, use a wildcard as the name of the first. You can use it and let to discard the output. Okay, so this seems closer to production code. Although again, I still like the compile error, to be honest. I'm not sure. I'm kind of on the fence here. I would leave it like this because I want the Rust compiler to work for me. So then if somebody comes in and changes it, they'll instantly get an error. Instead of them... Because what if they never hit this branch? Yeah. All right, good. Good. So I'm not going to do this because I understand what this is. So... for the first term, parents are valid. For the last term that covers, the parents are certain to the runs. But its special is those unused vars. This code compiles even though we haven't listed all the possible values because the last will match all values not specifically listed. Sure. Rust also has a parent want to catch all but don't want to use the value. Underscore. Special parent matches any value does not bind to that value. This tells Rust, so Rust won't warn us about an unused variable. Enums check in order. Oh, okay, that's a very important... You mean match checks in order. right? What? Yeah, match in general. Like it doesn't. Yeah, okay. That's an important detail because the order of these. Well, I guess for enums it doesn't matter because you can't have two arms active at the same time, right? So let's put it this way: for no, but it doesn't matter for enums because you can't have a thing with two types at the same time. But it matters for logical stuff like if you do, you know, are you rich or something, and you take cents, which is U8, and I do match cents. Wait, can I do logicals here? Like, oh no. I can't write stuff like greater than 10 or less. I can't do cents less than 10. False. No, no, hang on. So I'm trying to do a more basic match. Is this valid Rust? It is not, right? I'm making stuff up. Like you cannot do stuff like this. You have to do if else, right? Yeah. Okay. So match doesn't work with. You can't have expressions on the left hand side. Can you have Rust expressions? No, you can only use patterns, not arbitrary expressions. Oh shit, you can hide an if in there. Oh, I see, because that's... Oh my god, okay. I see. So if... so I can just hide all these? Like if sense is 10... Okay, this looks like horrible code, by the way. Like, let's not even... yeah, let's not even... I can't even tell what pattern. Now, what the heck did I... Yeah, I know. I'm just trying... No, no. Obviously, if let it... Okay, so then, wait a second. Why do we bring up the order of matching? What do you mean by it matches in order? Because for enums... Like, these are guaranteed disjoint, right? So it doesn't matter what order... Oh, you're talking about, like, runtime optimization? Or, like, it actually goes through them at runtime? Is that what you meant? Or... No, hang on. If you mean in terms of complexity, you're saying it makes sense to order your most common one first, right? If that's what you meant. Okay, that's okay. Yeah, yeah, I see. No, that makes sense. So it crudely goes through them in the order you write them at runtime. So then you want to optimize. Yeah, 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 yeah. Okay, I understand now. At runtime. Yeah, yeah. It's not at compile time or yeah. Matches are top-down checking. That is pretty... So the compiler doesn't know how to optimize? I guess not, because it would have to be branch prediction from the CPU. It's lower level. Yeah, the compiler can't do anything to rearrange those. That's good to know, though. So put the most common match at the top, basically, to get performance. All right. Rust has a match. Let's change rules again. Now, if you roll anything, you must roll again. Sure. Dice roll. But I don't understand. What do you mean it can do? Because the enum is guaranteed to only hit one branch. What is the side effect here? Because I know the coin is 1 out of 4. It can't be 2 at the same time. Oh, you can put the wild card not last? Oh my god. What? Okay, sorry. Wait, so this works? Okay, then this is a disaster code. Okay, I see. Okay, like obviously the wildcard has to be last, right? Like any sane person will... Yeah, yeah, the coin will consume the... Well, it has to be in the sense that it's like good programming because the compiler lets you do it here, right? And it does give you 127, which is the wrong answer because I entered with quarter. But yeah, I understand. Obviously, like no sane programmer would put this. I mean, it doesn't even make. I'm actually surprised it lets you compile this. Like, what does this even mean? Like, coin. I'm actually surprised you can compile this because this is a completely dead branch now. I guess it just warns you. Unreachable. It doesn't treat it special. Interesting. But yeah, you just trapped yourself here because you can put this first and then obviously you destroyed your whole logic, right? And this still compiles, I guess. It does. Yeah, interesting. I would have made this... I don't even know what the use case is then for not putting this last. Why does the language even allow it? But why does the language even allow it? Like, I would just ban this. Like, it has to be last. Interesting. It's more useful with a complex structure of data where you want to like intentionally stub out functionality, I guess. Because it is a complete stub if you put that in the middle. Okay, so maybe I see. Not literally a plain. Yeah, the plain wildcard is killer, right? Because it cuts everything off. You never want to do that. Yeah, okay, so it's... Maybe it's like partial wildcards or something, or yeah. Okay, so they do a bunch of stuff here. I have no idea what's happening here. There's a non-return, an empty tuple, not, what is this called? Singleton return? Unit value, the empty tuple type. We'll change the rules one more time so that nothing else happens on your turn. We're turning Rust explain we aren't going to use any other value that doesn't match a pattern, and we don't want to run any code in this case. Okay. Alright, are we ready to move on? Concise. Okay, if, let, and let else. Well, somehow this seems easier than match. I don't know why they do it in the reverse order. Because this one's easier to understand. The if let, let's combine if let to let's reverse him and match one power on the rest. Consider the program as matches on option. Still, the match seems... I guess you can break this in if, let... Yes, because you don't want to do anything. So it's just the basic if. The syntax, if, let. Oh, it's also an assignment. So match config max. If, let, sum max. Takes a pair of expressions separated by equal sign, works the same way as a match for the expression given to the match, and the pattern is its first term. In this case, the pattern is sum max, and the max binds to the value inside sum. We can then use max in the body. And then nothing happens if this is... Okay. Using if let means. Hey, thanks for stopping by on Twitch. What other languages do I know? A lot of Python. You'll find a bunch of stuff on my YouTube channel. Are you talking about like programming languages or human languages? Speaking for programming languages, right? Yeah, I'm basically a Python guy. You'll find a bunch of stuff, bunch of Python stuff on my YouTube. Rust looks suspiciously like Python though so far. Yes, humans a different story. Yeah. We can then use max in the body of the if. And same we use max using if type. You lose the exhaustive checking match enforces. Nah, just Python. There's no way. I've never touched C++. I know C. Oh, you're talking about Rust. No, it's way closer to Python than C to me, at least so far. Which is a good thing, I think. But yeah, it is. I've heard the thing about Haskell. I've heard it before. I don't know what Haskell is though, like zero knowledge. But yeah, I've heard that said before, for sure. Okay, so if let is just syntax sugar for a match. We can include an else. Haskell. Yeah, I'll have to look at that. I don't know what. I've never seen Haskell ever. Staying on the happy path with let else. What the heck is this? The comparison to perform some computation when a value is present and return a default. Continuing with our example of coins. If we wanted to say something funny, depending on how old the state on the quarter was, one interesting method. Yes, that is true. Rust seems suspiciously close to Python though. Continue, especially the Haskell. Some of this tuple stuff and destructuring, etc. Yeah, syntax wise for sure, yeah. And the concept of method and self, like, this is very Pythonic to me. Even the arrow annotation, we use this in Python to annotate the return type. It's a small thing, but it makes it seem much more familiar to me. As opposed to C style, where it's like, I guess it's in front of the function, the return type. Trying to say something funny, but might introduce a state. Shit, let me try this. What's happening here? So we implement a method for US state existed in the year. So all right, what the heck is going on here? So let's see. So I have a coin from Alaska and so what? I get the state. So I do a match on the coin. Uh-oh, I think I'm lost here. Hang on. How would I use this? So I implement something. The problem is I implement something for a type that's hidden inside the core enum. How can I reach it? Okay, so this is how. Oh yeah, I'm not supposed to derive debug there. You're right, sorry. So what's happening here? So I take the whole coin and if coin, quarter. So first I match if it's a coin with a quarter. If it's a match, it's a quarter, and then this unwraps the state implicitly. Okay, this is what I don't know. Okay, I see. So I can say something like, if let coin, no, it's coin, quarter, state, and nothing, because I don't care about the thing, is coin. Else, if it's not a quarter, I can do nothing. I guess I'm not gonna do anything then. So for all quarters, now I can check their state, right? So if state which is now an unwrapped US state, so existed in $1800, because I'm in Alaska, then I can do an else, and I can say stuff like, this is an impossible coin. Well, this is a fake coin, right? And this is a real coin. Now, let's see, did I get the syntax right? I did. Except... Oh, what? Because Alaska did not exist in 1959. Oh, sorry, I got the arms wrong, obviously. So if the state existed in 1800, it's a real coin, otherwise it's a fake coin. Okay. Yeah. Well, this is pretty complicated, like from syntax. I think we kind of drifted a bit, but so I can cut this. So what's happening here? So first this is a hidden match here, which only matches on one arm, and default everything else because there's no else. Okay, so I could have written an else. This coin is not a quarter. And then if I try to do another coin, it should hit that, like a nickel or something, which has no backing. Storage. Oh shit, I should not have deleted the... okay, I'm just gonna comment this, sorry. Okay, good. So the first one is an outer match. And then if the coin is this, then I can unwrap its state and its city if I wanted to, but I don't want the city. And then I can call... Can I annotate this? Is this valid syntax? Because it's annoying me that I don't know what type this is. I don't think I can. Oh no, I cannot. So how do I know? Is there really no way to annotate this? Like... Because I have to look at what this was, and then I have to go all the way here to figure out there was a state. Like, is it like this? It's not. Check the type definition of what? Because I have to flow all the way through quarter. And... yeah, I would need an IDE. Yeah. This is vanilla Rust. It's even in the web editor. Like, I don't even have... Yeah, this is my problem because I don't know what this is. So then how would I know to call? But okay, fine, sure. I guess I'm a big fan of type annotations. I would really prefer to see what this is on the fly, but fine. Okay. Okay, so I think I get the let. It's pretty complicated, but well, maybe not. It's just an unwrapping trick or destructuring trick. Oh shit, this is bad code though. What is this? That gets the job done, but it has pushed the work into the body of the if let statement. Okay, wait, there is a solution then. Oh my god, this looks horrible though. What is this? So it might be hard to follow exactly how the top level relay. We can also take advantage of fact expressions produce a value either to produce the state or to return it early. So I could do state equals this whole thing. Yeah, that's the thing. Everything is an expression. Yeah, so I could do state is directly the unpacked state if it exists. If the coin is of type quarter and I destructure the state, then state is state. Otherwise, it's a none. And then yeah, let me switch to this. But the problem is, so wait, I can call the method existed in even if this is none? Because this is not... Whoa. So what's happening here? So let state is if it's exactly this thing. Okay. State else none and semicolon. Okay. What is different code? Because then he checks... No, it's the same. It's exactly the same function re-implemented, right? But then my question is... Oh my god, I'm so dumb. Sorry. It's return none. You're right. Okay. Okay. Good catch. Okay. So this completely terminates the function, like the whole main function. Okay. Well, this is bad code though. Wait a second, because this basically... Okay, this is bad. This is... Yeah, this is okay. So this is a bit annoying to follow in its own way. I like the first one more, to be honest. Good catch. Yes. So to make this common pattern, Rust has... Okay, so there's a third pattern. Let else. The let else syntax takes a pattern on the left side and an expression on the right. Very similar, but does not have an if branch, only an... Only an else branch. If the pattern matches, it will bind the value from the pattern in the outer scope. If the pattern does not match, so let coin... Okay, so this is implicitly the if now. Let... If the pattern matches... Yeah, so if this is possible, I guess this is a pretty complicated... Yeah, this is also hiding like a whole unpacking here. Yeah, no, this is not good either. Return none. I still think I like the first one best, right? Because it says if I can unpack this, then I unpack it, and then I can safely call I know I can call on this branch because it's unpacked. Otherwise, I can do none. Which I guess this one is also return none, by the way. Oh, we've now covered. Okay, all right. Finally, I can go back to. All right, let me go back to rustlings. Finally. Okay, so we did a bunch of stuff. No fucking way. There's more pattern syntax. What do they want me to do here? Oh my god, this is advanced. Okay, fine. Well, I feel like we know this though. We went through all of these. So matching literals. Okay, we know how to do this, obviously. Matching named variables. Named variables are irrefutable patterns that match any value. This is many times. Or it's a complication when using a match if let. Because each of these kind of starts a new scope. Variables declared as part of a pattern. Oh god, there's some shadowing. We declare a variable named x with the value sum and the variable y. We then create a match on the value x. And sum y shadows. Okay, let me try this. I gotta try this. Hang on, something fishy is going on here. There's some shadowing happening here. But I think I can see what's happening here. So I start with x, which is an option. Well, it's an option type. Then y, match x, sum y. Then I unpack the 5 into y. So this will be 5. And then it goes back to 10, I would hope. Yes, it goes back to 10. Okay, so it's temporarily shadowed inside the scope, which makes sense because then this drops out of scope inside the arm. So then, okay. The pattern, the second match introduces a new variable that will match any value inside something. Because we're in a new scope, instead this is a new y, not the y we declared at the beginning. This new y binding will match any value, therefore this new y binds the inner value. If x had been a none, the parents in the first forms would have matched, so the value would have matched the underscore. We then introduce the x variable. When the match expression is done, its scope ends, blah, 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 blah. To create a match that compares the values of the outer x and y, we need to use a match guard conditional. Holy shit, there's so much to read here. Matching multiple patterns. Oh my god, I think we talked about this 2 streams ago, but yeah, there's the OR too, okay. Pattern OR operator. This is just logical OR then. The following code we match, okay. Matching ranges. Okay, sure, I've seen the range syntax. 1 inclusive 5. Again, very similar to Python. Ish. If x is 1 to 5, the first time the syntax is more convenient for multiple match. Well, that's what the rustling. Oh shit! Sorry, I'm still in the. Sorry, I'm reading. Sorry, I desynchronized because the rustlings they wanted me to go to pattern syntax. And we did a bunch of these already. So shadowing. Sorry, yeah, I had the VS Code on. I think it should be fine now. Yeah, so I messed around with this. This is fine. I was here. Logical OR. The ranges. Char values are also ordered. Sure. Destructuring. We know this already. Okay. So I can destructure the struct. Yeah, I can destructure a struct by point splitting it into X and Y. So then I can directly match on a struct like this. Whoa, what is this syntax though? Is it... Oh, it's match on X on any X, but Y is 0, right? So any point that has Y 0, and this one is the opposite. Any point that has... Yeah, no, the deconstruct I get, but the logic is that this will hit any point that has Y 0. If Y is not 0, it proceeds to the second one. So then if X is 0, it hits this one, and then default. Okay. So I guess for this can get exponentially large for like multiple fields. There's no way around it though. Yeah, the first term will match any point. Blah blah blah. Enums. Okay, we've seen this. We know how to match enums. Okay, so this is just a match syntax. Oh yeah, for sure. You can have 15 here, right? I can match on a point. Check this one. Like that has a 2 and some Y, right? So how do I test equality? Or wait, I think actually, yeah, can I implement this, what Race is saying? How can I check if a point has X equals to Y? So let's forget about this one. So yeah, so I only need one of those, right? Like if X, Y. And let's see if this works. And a comma. Let's see if I get this right. What did I do wrong here? Oh no, it's not print semicolon. Okay. And I forgot the return. I don't have the data structure for point. On the y-axis at 7. So then if I hit the 3, 3. Okay, so this works. Okay, I don't know the syntax though. Like I have not read about guards yet. So if it's equal. Okay. It's possibly here. Yeah, it's lower in this syntax. Lower in this chapter. The first armor matching. Okay, so a second. Enums we already talked about. We know how to match all the types in an enum. Change color to red, blah blah blah. We've seen this. Nested structs, and we've also seen this. Yeah, we've seen this with the coin and the state. So I can directly unpack the innermost things. Okay. And then for every other message I don't do anything. The parent the first time in the match. Structs and tuples. How far 1 point? I think, yeah, I don't think we can do that with match, or that's more of a functional calculation, it sounds like. Structs and tuples. Oh my god, this looks pretty bad. So I can destructure both at once. Yes. I can destructure a tuple, which is a tuple between a tuple and the struct. It is, but that is a that's a method, not a how far away. And we know in Rust it's supposed to take a reference to self, and it returns an F32. And I'm not gonna do the math here. I guess we want to put it unimplemented. Yes, we thought it's find first. It's find first. We were talking about this earlier. Destructuring, ignoring values. Yeah, we've seen this too. Oh yeah, we've discovered this one earlier. So the dot to ignore remaining parts of a value. Okay, we discovered this ourselves earlier. Sure, so you can ignore parts of a value with a nested. Wow. Oh, I see. So you can just check if it's sum, but you don't even care what it is. Arrest. I have not seen that one. Yeah, okay, you can skip selective ones, sure. An unused variable by starting its name. If you create a variable, Rust will usually... Okay, this is just a linter trick then. Just borrow checking errors. Oh, because this actually takes ownership here. I see. Oh, this doesn't take ownership. I think this is important to know. Interesting. This is a move then, right? Because you move it. This is like a match arm, basically. Yeah. This one is a match arm, but it does not take ownership. Okay, this seems important to remember. Yeah, remaining parts of a value. So it's just dot. It's like, I guess, in order. Oh, okay. This is super Pythonic, by the way. Like Python has exactly this thing, like first and last, and everything in between you can skip, and then you can do exactly this. No, you cannot do this because it doesn't know if it's the second or third, or obviously, yeah, this doesn't work. Okay, finally, a match guard. This is the first time I see this. Well, officially. Is an additional if condition specified after the pattern in the match arm that must also match. Also, it's like logical and. So it's if it matches that and the condition is true. Okay, so this explains why this works. So if it's a point and if x is equal to y, I'm surprised it's not just and then, or it's not and if, but okay. I guess Rust doesn't have and. Yeah. Capturing wildcards to be ignorable. Note that the condition can use variables created in the pattern. Oh, I see. Yeah, this makes sense because we did it here. You unpack, you destructure, and you can use them immediately. Okay, so sum the number is odd. You can use both this. I think I need to see that. Hang on, let's see. So if num happens, there is no way to express. Okay. And this works with something in the outer scope, of course, because y is visible here. It's not shadowed or anything. Yeah, this works, right? Y doesn't even change. Why do they print here? I don't understand, but I'm assuming y remains 10 here, right? Yeah, there's no change in y. Yeah. Score print creates a variable that doesn't shadow anything because there is no end. The match guard is not apparent, therefore doesn't choose new variables. This y is the outer y. Yeah, you can also use the OR operator in the match guard to specify. Okay, sure. So it's 4 or 5. It's either this, either of these, and if y is true, which in this case is not. Yeah, okay. So the precedence here is like I guessed it. So I don't understand what you mean then. So how would I use these together then? Like in the default? Let's say here, right? So what else would I do here? Oh no, or you mean in separate arms, right? Oh no, wait. Both the capturing wildcard and ignoring wildcard works with guards. So I can do stuff like this. So let's say I have some let external, check this out, true, right? So that, no, let's put it false. No hit, but no external. So I can do if external, and then I can also have another one. No, this is but external is true, right? Okay. But external is false. Okay, obviously we don't want this on the diagonal. Okay, good. So then if I flip this to true, okay, I see. So I can basically fake some branches that don't depend on what I unwrap, but they depend on external logic. Okay. Seems useful enough sometime. Although it does smell like global state, which you probably don't want to do. The match condition states, okay, so then we know how to do logicals, no problems there. After running the code using, oh, should I read this? Okay, I'm gonna read this one. I've never seen this before. Using at bindings. The at operator lets us create a variable that holds the value at the same time we're testing that value for a pattern match. We want to test that a message hello ID field is within 3.7. Okay, so I have an enum message, has only one type, hello, which also holds a struct with ID. I have a message with hello ID 5. I match the message, I unpack the ID. What the heck is this? ID at 3.7? Also, I actually bind it like... Wait, we want to test is it within, we also want to bind the value. Yeah, I'm a bit confused about this one too. Like, what the heck is going on here? Like, that, I guess you yank of, so do I have the thing here then? Or what's, hang on. No, let me do this. Sorry. So do I have ID now? I can do like print line. ID is ID? No, it's not. I didn't bind it to a variable. Oh, it's only in this code because it gets dropped, right? But I don't ever use it here though. Ah, so here's some trickery. If I put underscore here and I hit this arm first, it binds it and then it prints it here. So for example, if I go with ID 15, no, because I need to destructure it here too. So why do I do it here? Okay, so hang on. The add creates a variable that holds value at the same time we're testing that value for a pattern match. We want to test that the message hello is within the variable. So we want to bind the value so we can use it in the code. Wait a second. So this doesn't work then? Oh, okay. It's just in that arm. It's even... Okay. No, that's the thing. It's even for... It's just for this arm, it seems. Like, I cannot use it here, right? So if I try ID 10... Yeah. I guess I have to do it everywhere. So, for example, here I do... Oh no, it has to do with the range syntax too, though. Captures for all values in the range. Okay, the syntax is a bit weird, so... Example print by specifying ID before the range. We're capturing whatever value matched the range. It's pretty ugly syntax. Yeah, like this has to be... It's only for ranges then? Like, it doesn't work for anything else, right? In the second arm, where we don't have a range of the specified pattern. The whatever... The second arm, the code associated with the arm doesn't have a variable that contains the actual value. The ID field could have been, but the code that goes with the pattern doesn't know. Oh, I see, because it's not, it has to be with ranges. Because, okay, the pattern code isn't able to use the value from the ID field because we haven't saved the ID in the variable. Where we specify the value without the range, we do have the value available. The reason is that we've used the struct field shorthand syntax, but we haven't applied any test. So it has to do with ranges. Let's assume. Okay, well, we jumped around pretty wild tonight. I'm gonna finally go back to rustlings. I have a feeling these are gonna be like super easy. Like we spent 3 hours reading about enums for 3 exercises. And they're gonna be like, yeah, it's like just type one line. But we've messed around a lot though. Define a few types of messages as used below. Sure. Oh my god, this is like echo, change color, quit. Okay. Trivial. Point. Captures remaining slice. Yeah. First rest. Yeah, that seems pretty advanced syntax. Define the different variants. I'm assuming Nate meant what you typed. The first rest at. And I'm assuming rest is also the reserved keyword there. Which you didn't use the double dot? Maybe. What the heck do I have to do here? Yeah, the whole binding thing. Yeah, we can. I think this is Rustling's fault. Like maybe I shouldn't even have read that. Define the different variants used below. Okay, so let's see. We have a quit. I guess I'll put them in order. So we have a resize, which is a I guess it's a U64 actually. Gotta be a bit careful here. Why is my point U64? I think it's U64. And height. At least it's idiomatic to me. So move is only a point. Echo is a string. Change color is 3 U8s, assuming colors are U8s. And quit is a plain. I think I got this right? Yeah, I'm a bit confused about the 64 here because I guess magically, so the point is 64. Well, the thing is we don't have an example usage. We only have a print, so the compiler doesn't. I think this is it. Okay, good. Oh my god, these are so easy though. What the heck? Why do we have to look at all the matching? Like, is this a joke or why did they have us look at matching? I guess for fun. Okay, this looks more like some programming. What's happening here? So create the match. Oh, okay, never mind. Here it is. Create the match expression to process the different message variants using the methods defined above. So I receive a message. So I match on the message. And I have 5 options. Message, resize. Oh shit, I have to unpack width, height, and what do I want to do? To process the different message using. So I have to call resize. Uh-oh. I don't know how to call a method from another method. Is it self.resize? That's what I would do in Python. Like, how do I call resize? It's state.resize or is it self.resize? I think self is more idiomatic, right? And I have to call it with width, height. Okay. Okay, what else do we have? Move. So match on move, which is what? Uh-oh, it's a point. I forgot, how do I unpack the point then? Like this? I think it's like this, right? And I want to move. Oh, but I don't need to. Wait a second, it's even more complicated. So, oh, wait, it's easier then. So I just need the P point. Is that how it is, or is it just P then? I think it's just P. Okay. So it's self move P then. Yeah, okay. Okay, this is cleaner. Yeah, because I don't need to unpack it. Okay, so self move move position. And what else do we have here? Echo string, which is S. And self echo S. Now, they didn't take references. I did the, yeah, okay, I did unpack it. So, okay, let me do it this way then. So, what if I do this? Let me try this. X, Y. And I believe I can also do, I mean, it looks gruesome, but this is also all right, right? I can just pass this, I can unpack it and create it on the fly and pass it back, right? This is valid. Honestly, I'm kind of on the fence here. It's yeah, it's different. Yeah, no, yeah. So P is cleaner, but yeah. Okay, the string is string. This one is easy. Change color. Uh-oh, shit. How do I unpack 3 things now? Let's see if I remember this one. I mean, these are all syntactical. Like, it's... I was gonna say that. The process itself captures... Oh, wait a second. So is there some borrow checking subtlety here then? Whoa, wait a second. What does that mean? So if I do this... Because he wants a point. This should work, right? Or is it that because I created like this on the fly, it goes... Just mean you can use P without causing havoc. Yeah, but I can also use XY here unwrapped without causing havoc, right? There's no subtlety here that he wants a point. Process takes ownership of P, yes. Process takes ownership of P, so it's fine. But yes, unwrapping is fine. But of course, okay. Well, now that we're talking about this, hang on. Let me ask you something else. So what if this was a reference? Which is pretty benign. So then if I unpack it with P, it's just a reference to P, right? This seems to work. Although I don't know if this equality syntax works. If it's referencing to give it a P, yes. And do I have to do the dereference here by chance? I didn't get to this, but, or is this, I think I have to do the dereference, right? Also, for the assignment like this. Just by guessing. Yeah, okay. Okay, but now hang on. We got to this. That's not my real question is now, what if I unpack it like this? What is the... Ah, shit, it's not gonna work, but okay. You're right. I didn't unpack. Let me take this actually, because I want. Hang on. That's not my real question. I have something more complicated too. Dref would call copy. So I can just derive it then? Can I get away with deriving it? Or is it not that easy? Dref. Or is it not that smart to do it? I think it is smart because it's just two basic types, right? Oh, it has to be manually derived. Can you auto derive dref? Oh, okay, you have to use a crate. Okay, fine. Let's do it that way. Okay, because I think I'm going to stop after this, but let's do the full thing. So, impl. I don't know trait. I'm going to guess that it's at 4 point. I don't know the trait syntax at all. Actually, I don't know what this is supposed to do, to be honest. Let me peek. Okay, I'm gonna just one time I'll peek a bit at it. Yeah, I'll look. Yeah, so dref trait. Examples. There we go. So we have a struct with a value. Okay, so use standard ops. Okay, dref. Okay, so we need to import this. All right. Do I have the right screen on? Yes, I do have the right screen on. Import t. I don't need a t here, right? I just need dref for point. Not sure what or do I need this whole syntax, target syntax? Derive, copy, and clone. Yeah, because I switched the problem. I made it into a reference intentionally. The thing is, there is another question I have, but in order to get to it, I need this to work. Okay, so I don't need the type. Yeah, okay, so I'll just put type target point. Okay, dref self dot. Unfortunately, I don't understand this syntax. So what does this have to do? Like, it takes a mutable reference to self. And it expects to return a new instance of the point. Like a clone, basically-ish. Like, I just take from this reference and I create a new structure and I return it. That kind of seems like what this wants, right? So basically, it's just point self.x self.y, because these are cloned automatically. Or is it a reference to it? Damn it, it's a reference to it. So a reference to this. This looks kind of right. You know what the funny thing is? This is what I wanted to ask. Okay. So P. Okay, so let's try the main. So I can do let, oh boy, P is point 1, 2. And I need a message. Okay. Maybe I should not have deleted those tests. The tests. Okay, I'm gonna take the state from here. And I want to move. Okay, so I have a state now. It has a bunch of stuff in it. And I just want to process the message that is called, which one's the complicated message? Move is the one we want. Hey, thanks for joining, stopping by on Twitch. Master Programmable Elemental, what does that mean? Move. All right, let's see. We did a bunch of circuits here. Let's see if this builds. Oh my god, it does not build at all. Why? Oh, it's because I don't know how to create the struct, right? Is it like X and Y, obviously? Okay. Match arm with no body, of course, because I forgot to do this thing. I think so. I think I'm gonna ditch this. Yeah, but now I dug myself in. So might as well try to. I'm sort of skipping ahead a lot. Yeah. Okay. So now, well, hang on. This is a good borrow checking and syntax issue. So what the heck did I do here? Okay, because at the end of the day, this is just references. Like. Cannot return reference. Oh, okay. So I know what I did here. Oh, see, this, I didn't know about this. So this doesn't work in Rust. Then this answers the question I had. So what? I need to create this manually, and then I need to return a reference to new point. Is that what he wants? Cannot return reference to... Why am I hitting borrow checking issues? Returns a reference to data owned by the current function. And this is not possible in Rust? Aha, very good. Yes, see? This is a good exercise. Damn it, you're right. So what do I do here? So let new point is dropped. Oh shit, so how do we get around this then? Assuming this thing wants to return a reference to your own class. I guess I know what you meant now. So you just want to do the plain clone. Okay, I just destroyed everything. Okay, maybe this is a bit too advanced, yeah. Does it have to do with lifetimes and stuff? Do I need to annotate the lifetime, or what am I getting wrong here? Yeah, so I'm only allowed to use self. Let's keep the reference to right clone and copy and call clone in that function. Well, okay. Is it just as easy as returning self? I don't think so. Maybe it is, but then I get the new error. Okay, so I see. So I need to derive clone too. Cannot move out of point, which is behind the shared reference, which does not implement the copy trait. So it wants these anyways. Oh my god. Okay. So this whole... Okay. So just derive call and copy and call clone in the function. Right. So then... Yeah, okay. So it would be new point is point. No. Hang on. What's happening here? Yeah, I got tangled up. Let's... Okay. All right. Let's... No, you're right. I got tangled up a bit. Hang on. Let me go back here. So... self position is clone. That would copy due to implementing the trait. Well, here's the thing though. So the original problem, because I changed the code, so it only had just a point. But I'm not allowed to change this though. No, so it's fine that it gets dropped though, right? Because I just lose this point forever. But it doesn't matter because I'm already in a match arm. I think. Because I didn't write... I'm not allowed to change this code. It's just an assignment. But yeah, you're right. It is weird they don't clone here. Actually, why is it fine then? Because if this goes out of scope, this gets dropped. So this data points to... Where's the clone happening then? Yeah, no, I changed it back. Yes. But still, even in this case, why don't I need the clone then? Because this point will get dropped once this function exits. So this is a clone because it's of basic types. Okay, so I give ownership to self position. I see it's not a reference, so it's a move then. And I guess self is a magic keyword and it does not get dropped when this function... Because this is a mutable reference. Okay, now I understand why this is a mutable reference. So it's a... Self itself is a mutable reference. So then I move the point into self.position. Then, exactly, then at the end of the function, point gets dropped. And the reference self also gets dropped. But it's fine because it's just a reference. It's not like the underlying data gets dropped, right? Behind the whole state. This is why here passing self as reference is critical. Otherwise, if it would have been this would be a disaster, right? Because I lose the whole data once it goes, once this function ends. Or I guess mutable self, if that's even possible. All right, so let's go back. Yeah, this was I was just messing around. Okay, so then echo, change color, 3 integers. Is this how I unpack it? I think so. Destructure it, I mean. Red, green, blue. Is there a I have an idea here. We should use that dot syntax, but we'll see. And then if it's quit, self quit. I think this is it. Yep. Okay, there we go. Now Okay, so this was pretty easy. The idea I had is, can we get rid of all these? And I say dot dot. And then can I also get away with dot dot here? No, there's no way, right? Like, does it know how to pass them through? Nah, it doesn't work. It wants 3 explicit. That would have been so Pythonic, but yeah, I guess the compiler gets messed up because it, well, not really, because it knows the types, but yeah. Okay, well, that was it for enums. That took way longer than for these exercises. Were pretty disappointing, but we did mess around a lot. Yeah, it doesn't. Okay, you're right. So there's nothing. If I do this, it's lost forever. Yeah, the trick doesn't work. Like, there's no pass-through trick. Yeah. Strings, what do they want me to do? Rust has 2 string types. Well, I mean, we can just do this for fun. Let's just do the exercises. I think I can do these because we read so much now. All right, so yeah, this one I can just fire. Okay, okay, so this is string from. I think, wait, is it? Yes, it is, right? Yes, it's actually the string from. Nice, okay. Because we messed around so much, I'm starting to get familiar with these now. Fix the compiler in the main without changing this function. So is a color word a reference to string? Let word string from green. Is a color word word? What is just a reference? It must be, right? Okay, well, that was pretty easy. Oh boy, maybe I messed up. So what the heck does it want me to do? Remove whites? Holy shit, am I supposed to know the methods to do this, or? Whoa, this seems insane to do this by hand. String slice, yeah. Oh my god, so wait, do we actually need to do these by hand? No, these are about methods, right? Like we need to do this with methods. I'm not gonna do this by hand, like walking through all the. Because I don't even know how to iterate. Like for what? Character in input dot iter. Damn, maybe I did need to read the string section. So we know how to create a new string. Do we know how to iterate? Updating a string. We know how to push to it. The thing is, I don't know all these methods. String methods, Rust. Okay, so how about we do it this way then? For this one. Yeah, exactly. Because I don't understand if the exercise wants me to do them by hand, but I'm not gonna do that by hand because then it's like lead code basically, right? So okay, so push is a character, push string, push is a whole string at the end. Oh, what the heck else do I have? I have length. I have dot chars, so I can iterate through chars, I guess. I can get the nth character. Deref, I don't understand yet. Representation. No, this is too complicated. Well, I guess I can get pointer length capacity. Okay. Yeah, I would have to search. Yeah, there's so many probably. Oh my god, yeah. Clear. Truncates the string, removing. Split. into 2 at a given byte index is empty. Length, insert. Insert a character at byte position index. So this is the most generic one. Reallocates capacity into bytes into chars is empty. Pop removes the last character. Push, remove. Removes the char from this string and returns it. Replace first. Damn, you know, maybe it is hard to find the so how the heck do we trim a string then? Does it have trim here, or am I supposed to actually... Oh, it has trim. Okay, well, never mind. This is lame, yeah. I mean, this is super lame. Honestly, I would just... Should we bother implementing this? So how would I do this lead? This is like an easy lead code at this point, which is not a bad exercise to try to do in Rust. So what I would do is I would walk through the chars and then test... Find the last index in the beginning that's not white space. How the heck do I walk through chars though? Into chars? Yes. So converts a string into an iterator. And then all I need to do is assert chars next. Should I try it? I think I'm gonna try it, because otherwise if I do the trim it's kind of lame. Okay, so it's into chars. Oh yeah, you're right. Oh my god, I'm not even gonna have this. Okay, never mind. Jesus Christ. So there's no way to go... This seems like such a basic thing, but I guess maybe not, because it's dynamically sized. Into raw parts. Can I index the string manually then? So is it like... Yeah, it's just iter, right? Where is that? Why is it not here though? I guess it's so fundamental that it's... So if I have let s is string from hello, and I go for c in s iter, print line c. Does this do what I think it does? No methods iter. It doesn't have iter though, because it would have been here, right? So then what? I have to go manual length, because I'll do it. It's not that bad. So I get for I in s length, print s of I. Oh no, sorry, 0 dot dot, right? No, I can't index a string though. Can I get? I can get. Return a sub slice. But why can't I index the string though? I'm a bit confused now. Maybe let me read the book more. So I can append, sure, concatenate with plus, add, indexing, okay. Right, so I cannot, Rust strings don't support indexing. Oh, it's chars? Wait, hang on. Let's read the book, because the book seems nice here. So it says clearly, Rust strings don't support indexing. Why not? Okay, so we know how it stores because it's like the fat pointer thing. Oh, because it's Unicode or UTF. Takes 2 bytes of storage. Slicing strings. Iterating over strings. Oh yeah, it is chars. Yeah, you're right. Okay, so it's chars. All right. So then I can go for C in S chars. Print C. And chars doesn't then. Returns an iterator over chars. As strings I consider can iterate to a string size by chars. There is such an iterator. It's important to remember that char represents a Unicode scalar value. Chars might not match your intuition. Well, I guess it won't matter too much because for the exercise okay, let's just do it in the playground then. All right, so let's not even bother with the rustling. So then I print the chars. This should work. Okay, so now what I have to do is I have to trim the white space. Into means to take and make into, and the one without doesn't take on, doesn't move then, right? Yeah. Okay, so let's do it this way. So let to trim I32 is -1. Okay. And then we say if C is white space, to trim +1, else break. So now we know exactly how many we need to trim. Okay. So now I'm gonna use a method. I'm not gonna do the trim manually. Well, no, because I'm doing it the lead code style. I need to walk through the characters. I need to trim the leading white space, right? I guess how would I do it with match then? Because I need a +1. I need logic to... Can I assign an expression? Can I do match? Ah, you're right. Damn it. Okay. Yeah, it's too... Wait, aren't those formed of... when those come into chars, aren't they chars though? Like a T is 2 chars? No, not the new line though. Yeah. No, but the new line is not for sure. I mean, the tab is 2 white spaces, yes, but... or maybe it's not even. Maybe it's a separate char. I don't know how it works, but... Actually, I don't know how the new line works when you get it in chars then. Yeah, no, okay, we're not doing this then. Never mind. It's too complicated then, yeah. Oh, it's a single char. Yeah, but it's not a white space, right? So, okay, so then what you're saying is I match on C. And if I see this or tab, or I don't even know what the R is, but whoops, I made a mistake, by the way. All these are wrong because they're chars. There we go. So this is char, 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 char. Why is the syntax wrong here? What am I doing? So what do I do here? Can I do this? No, I can't. Oh, I see. So I need to do 1, But so the thing is, I can do an increment, right? Like let increment. Well, I guess I can do 2 trim plus equals the match, which gives me either 1 or 0. The problem is I need a break though here. So if I hit this, how do I break? I need to break. I don't think this works, right? Let me see if this is valid syntax. No, it's not. Because it's mutable. This one's easy to fix. Okay, this works, but it doesn't break though, because I only need the leading white space. So as soon as I find a 0, how the heck do I get out of here? I still need an if. I wonder, you think this works? Like what? Oh, like, I think you're right. Like, is it rust break in match? I think there is this break outer for loop. I've seen this in the loop label. It works just with the loop label. Okay, we're doing it with the loop label. I know this one. Okay, so then we gotta do it this. Oh no, but the loop label. So I need an option here. Does chars give me an option too? And it gives none if it flows out of bounds? No, it's not an option. It stops. Oh no, it does, because it's next. Okay, all right, so here's what I do. I get an iterator. Oh God, okay. So let's see is as chars. Okay, and we say like this. Okay, hang on, this is gonna be pretty bad. So we loop and we call it outer. I think this is the syntax, right? Yes. Oh no, it works with 4 too. Okay, it's easier then. We don't need a manual. Never mind. Interesting, I didn't know this loop labeling works. Okay, so then I can... So how did I break it? Yeah, break, it does. I can just break the loop, so I don't even need the 0 then. So it's just break outer loop then. Why did he put semicolon there? I guess I need this. This looks really sketchy, but sure, let's try it. Oh my God, I think it works. No, you need the... Oh, you don't even need the label, you think? Let's try it. I think you need the label. It's the only way to break in... Nah, you're right. Okay. So then we print... to trim, which should be... I guess what? 2. 1. Because it's up to index 1. Okay, and if I put what? A new line? Okay, and I put A and the space. All right, good. So now we can trim the front. And I guess I need to make the string mutable too. Maybe no, no, I do need to make the string mutable, right? So then we can say S, how the heck do I trim up to an index? Okay, this one I'm not gonna do by hand, because now I can say, how do I split or how do I cut an index? Oh, I just slice it, right? So, um, damn it, I wish I knew how to do this. Like find get is empty length lines match parse repeat replace are fine. Sounds like a split. No, split. No, these are all iterators. Split once. No. Strip prefix. No, but I don't know what the prefix is. Oh my god. Trim left. No, this is deprecated. Trim start. No, this already takes care of the white space for me. Substring range. No, it's complicated. I think it's just a slice syntax, and I'm overcomplicating this because it says so in the string. Yeah, it's just a slicing string. So you get a new, okay. So then I can just shadow it. I mean, I cannot shadow it, but assign it. No, it is a so it's a reference to string from to trim onwards. Let's see what we did here. Probably disaster. Maybe not. String indices are ranges. Thanks for stopping by. Yeah, it's pretty much done. Yeah, thanks. We did the enums and the strings. Yeah, thanks for stopping by. I'll stream next weekend. Appreciate it. So what do we do here? Oh no, let me see. Damn, if only I knew how to index a string, that would help me a lot. What the heck is happening here? So this is a string. Here, S will be a string slice that contains the first... Oh no, but it's bytes. Never mind. How do we slice a string in bytes then? Slicing a string with chars, not bytes, in Rust. You cannot slice. Jesus Christ. So how do I extract it? Oh, it's take. With char range. Yeah, so it operates on bytes, but it's UTF stuff, so they can take in for 1 for 4 bytes. Alright, well, we're dead. I'm not gonna do this. We'll do it next time. Okay, so definitely have a lot of stuff to learn. The problem is, okay, sure, so I can do the trim here, which I should have done from the start, but then it's just return input dot trim. There we go. Congratulations. Which is really lame, right? This one is let s let me just finish this. And so I'm a bit confused about the string slice though, because he wants a new string. So string from input and s dot push space world and s, I guess it's push str. Let's see now. We have to check the docs again. So string. So definitely I saw something with push. PQRS. Dude, where are all these things? Push str, yes. Append the string. So definitely okay, and then that's a string. So the push is good. Yeah, and I guess it's from a reference. Okay, so I got it right. Did I get the trim right? Probably, possibly. Yeah, it's literally just trim. So it takes self and it returns a slice reference too. So that's exactly what we needed here. Input trim. Okay, s push string world s replace me. Okay, well we have to look this up too. There's no way we're doing replacement. It'll take like 1 year. Okay, well this is also super easy. Like what the heck? So it's just dot replace. Okay. So it will be let s cars with balloons, and I just return s. Of course these are all mutable. God damn it. Okay, I fell for mutability. 2 passed, 1 failed. Was I not supposed to replace? Oh, the replace syntax is in reverse. From to. What? So it didn't say to replace cars with balloons? Which one did I fail? Did I mistype balloons? No, I did not mistype balloons. Oh, come on, dude. Seriously? Am I supposed to? I'm so dumb. This is not in place, is it? So it's just returning this. And I don't need it to be mutable. Because I returned something new. Yep, okay. Alright, well this was pretty nasty. Let's leave this for now because we're having trouble with strings. So next time we'll start it again. We'll do more strings next time. Well, thanks everyone for watching, stopping by. I think this is a good stopping point. We did a bunch of stuff today. Actually a bunch of stuff. Like, yeah, we went through enums. We spent a lot of time on enums and matching. We also kind of ended with this string thing, which is not bad. Definitely getting used to Rust syntax. Now, yes, this looks horrendous, but I understand all of it. So I think the match helped me understand a lot more. Definitely getting used to references now. Definitely getting used to cloning. So I can already see some of the pitfalls there. Next up is I gotta look at traits properly. And generic types, lifetimes. I think we're getting there though. Yeah, generic types, traits, lifetimes. That's pretty much it probably syntactically. So pretty good we're doing. So maybe we'll start something more concrete. But yeah, we'll see. Thanks for watching and I'll see you next time.